From ancient stargazers to modern physicists, humans have always wondered about bending space and time. Today, we'll explore fascinating theories about cosmic portals, from Einstein's groundbreaking ideas to cutting-edge NASA experiments that challenge our understanding of time itself. Ancient civilizations were more advanced in astronomy than many people realize. The Egyptians built their pyramids with incredible precision, aligning them perfectly with the stars of Orion's belt. They used these massive structures as cosmic calendars to predict the annual flooding of the Nile. Meanwhile, across the ocean, Maya astronomers created detailed charts tracking Venus and other planets with amazing accuracy. They built special observatories like the circular tower at Chichen Itza to watch the sky. These ancient sky watchers noticed patterns we're still learning about today. They recorded solar eclipses, tracked the movements of planets, and even spotted comets centuries before modern telescopes existed. Their stone calendars and building alignments weren't just for show. They were sophisticated tools for understanding the cosmos. The really cool part? Many of their calculations are still accurate when checked against modern computers. Let's dive into one of Einstein's most mind-bending ideas: wormholes. Back in 1935, Einstein and his colleague Nathan Rosen suggested something amazing. Space could fold like a piece of paper, creating shortcuts through the universe. Think of space as a flat sheet. Now imagine folding it so two distant points touch. That's basically what a wormhole would be. Einstein showed mathematically that these tunnels could exist according to his theory of general relativity. While he called them bridges, scientists later nicknamed them wormholes because they're like tunnels a worm might make through an apple to get from one side to the other faster. The math was solid, but there was a catch. These theoretical tunnels would be super unstable and collapse instantly if anything tried to pass through them. Still, Einstein's work opened up a whole new way of thinking about space travel and inspired generations of scientists to keep exploring these cosmic shortcuts. Let's explore pulsars, some of the most amazing objects in space. These spinning stars are like cosmic lighthouses, beaming radio waves across the universe with perfect timing. A pulsar is what's left after a massive star dies. Imagine a star packed down to the size of a city, spinning hundreds of times per second. These space oddities are so precise that their signals could be used to create the most accurate clocks ever made. When scientists first discovered them in 1967, they were so regular that researchers wondered if they might be signals from aliens. But what makes pulsars really special is how they affect time itself. Their incredibly strong gravity actually slows down time around them, just like Einstein predicted. Some scientists think we might one day use pulsars' unique properties to test theories about time travel and even help guide future space missions. Black holes aren't just cosmic vacuum cleaners. They're nature's most powerful time machines, as Stephen Hawking helped us understand. When you get close to a black hole, time moves differently than it does on Earth. Imagine you're an astronaut brave enough to orbit near one. While you experience just a few minutes, years might pass back on Earth. This happens because black holes bend space-time so extremely that they actually stretch time itself, something scientists call gravitational time dilation. Hawking showed that black holes aren't completely black either. They leak tiny amounts of radiation and eventually shrink. He explained that the intense gravity of black holes affects everything around them, even light and time itself. This discovery changed how we think about these mysterious objects and opened up new possibilities for understanding time travel. While we can't exactly use black holes as time machines yet, they're teaching us amazing things about how time works in our universe. The ancient Sanskrit texts contain some fascinating ideas about time and space that seem way ahead of their time. In the Mahabharata and Puranas, there are detailed stories about time moving at different speeds in different realms, similar to what we now call time dilation. These texts describe flying vehicles called vimanas that could travel between worlds and even dimensions. The Puranas talk about multiple universes and cosmic cycles lasting billions of years, which is pretty close to our modern understanding of cosmic timescales. One famous story tells of King Kakudmi visiting Brahma's realm, where he experienced just a few minutes while centuries passed on Earth. While we shouldn't take these tales literally, it's amazing how these ancient writers explored concepts that modern physics is only now beginning to understand. They saw time as flexible and cyclical rather than fixed and linear, showing remarkable insight into ideas we're still exploring today. Let's explore one of the weirdest parts of quantum physics: entangled particles that seem to talk to each other instantly across any distance. When two particles become entangled, they form a special connection. Change something about one particle and its partner instantly responds, even if they're on opposite sides of the galaxy. Einstein called this spooky action at a distance because it seemed to break his rule that nothing can travel faster than light. Scientists have proven this effect is real through careful experiments. They've even managed to entangle particles separated by hundreds of miles. This discovery isn't just cool science. It could lead to super-fast quantum computers and unbreakable codes. Some researchers think entanglement might help explain how time works at the tiniest levels, and it could even be the key to creating real-time portals between distant points in space. NASA has done some amazing real-world tests that prove time really does move differently in space. They've used super-accurate atomic clocks to measure how time changes at different distances from Earth. In one famous experiment, they sent atomic clocks up in rockets and compared them to identical clocks on the ground. The space clocks actually ran slightly faster. This happens because Earth's gravity affects the flow of time. The stronger the gravity, the slower time moves. GPS satellites have to account for this effect to work properly, adjusting their time calculations by about 38 microseconds every day. Without these adjustments, your phone's GPS would be off by miles. NASA continues to study these time differences with more advanced experiments, helping us better understand how gravity bends not just space, but time itself. Let's explore cosmic strings, some of the strangest objects scientists think might exist in our universe. These aren't ordinary strings, but incredibly thin, super-heavy lines that might stretch across the entire universe. Picture them as impossibly thin tubes, thinner than an atom, but so dense that just 1 mile of cosmic string would weigh more than Earth. Scientists think these strings might have formed right after the Big Bang when the universe was still taking shape. The really exciting part is how they might affect space and time. When two cosmic strings cross, they could create a tear in space-time, potentially opening a gateway to distant parts of the universe. While we haven't found any cosmic strings yet, scientists are searching for them by looking for their effects on light from distant galaxies. If we ever discover them, they could be nature's own cosmic shortcuts. Modern physicists are taking a serious look at the possibility of space-time portals, and their findings are pretty exciting. NASA scientists have discovered areas called magnetic portals, where Earth's and the Sun's magnetic fields connect, creating pathways for particles to flow between them. At the Large Hadron Collider, researchers are looking for tiny black holes and extra dimensions that could help us understand how to create stable passageways through space-time. Some scientists think we might find natural portals near black holes, where space-time gets extremely bent. The most promising research focuses on something called traversable wormholes, theoretical tunnels that could let spacecraft take shortcuts across vast distances. While we can't build a Stargate yet, the math shows it might be possible with exotic materials that have negative energy. Looking ahead, scientists are working on some incredible ways we might actually use space-time portals for real space travel. The most promising approach involves creating microscopic wormholes in labs and gradually making them bigger. While this sounds like science fiction, the math shows it's technically possible. We just need to figure out how to generate and control negative energy to keep these portals open. Another exciting possibility is using rotating black holes as natural space highways. Some physicists think their intense spin might create stable passages through space-time. We're also developing new materials that could help manipulate gravity in ways we never thought possible. While we probably won't have a working Stargate tomorrow, the building blocks are slowly coming together. The real challenge isn't just opening these cosmic doorways, it's making them safe and stable enough for actual travel. Thanks for joining me on this mind-bending journey through space and time. From ancient stargazers to modern scientists, we're getting closer to understanding these cosmic mysteries. If you enjoyed this video, hit like, subscribe, and share it with fellow space enthusiasts.